Hello and welcome to another tutorial. This time we are going to discuss the modified Proctor compaction test and how to use it on the MS Excel program. First off, what is the modified Proctor compaction test and its purpose? The modified Proctor compaction test is used to determine the compaction of different types of soil and the properties of soil with a change in moisture content. It's also used to describe the relationship between the dry density and the moisture content. For these types of problem, sa modified Proctor compaction test, ang given lang sa atin is ang moisture content, ang specimen mass, ang specific gravity ng soil, ang volume ng solid or ng soil, and ang unit weight of water. Let's begin. First off, to calculate the value of the moist unit weight, ang gagawin lang natin is to divide specimen mass divided by the volume multiplied to 9.81. Same formula lang din ang gagamitin natin throughout dito sa ating mga given values or data. Okay? Next is ang ating dry unit weight. Now, to get the dry unit weight, the same sa ating solution or sa ating process kanina sa standard Proctor test. The only thing we have to do is to divide the moist unit weight to 1 plus ang ating moisture content. So, ang ating moisture content is naka-percentage form. Pwede natin siya convert into decimal form to get our dry unit weight. There we go. Okay. So, ang ating void ratio, to get the void ratio, ang gagawin lang natin is to multiply specific gravity times 9.81. 9.81. Then, i-divide natin yan siya by our dry unit weight. Then, ang whole equation is to be subtracted by 1. There we go. Same process pa rin siya again sa pagkuha ng void ratio ng iba't ibang values na given. Okay? Next, for the degree of saturation. So, for the degree of saturation, ang gagawin lang natin is to multiply the moisture content and ang ating specific gravity. Okay? Again, multiply moisture content times the specific gravity. Then, i-divide natin siya sa ating nakuhang void ratio. Then, overall, multiply it to 100% para makuha ating degree of saturation. And again, same formula ang gagamitin natin sa rest of the values. Okay, at this point, pwede na natin agad makuha ang ating max dry unit weight. Para makuha ang ating max dry unit weight, ang gagawin lang natin is again, yung ginawa natin sa ating standard Proctor test using the function max. Then, ang ating gagamitin na values for the max is ang dry unit weight. Close the function. Then, 19.038 ang ating maximum dry unit weight. Now again, for the optimum moisture content, ang gagawin lang natin is to base our answers sa ating max dry unit weight. So, ang ating max dry unit weight is 19.038. Hahanapin lang natin ang ating corresponding moisture content, which would be 9.5%. Okay? So, kung makuha na natin yan, ma-identify na rin natin ang degree of saturation for the optimum moisture content, which is 66.83. Ganun lang. Pinpoint ko lang, dapat ma-identify mo lang yung max dry unit weight. Okay? Para makuha natin ang value ng optimum moisture content and ang the degree of saturations. Next is the zero air void curve. Now, for the zero air void curve, the same sa ginawa natin kanina dito sa ating standard Proctor test, nag-assume tayo ng ating value for our moisture content. Pero ang difference lang dito is iisa lang ating value ng ating zero air void unit weight. Now, to get the zero air void unit weight, ang susundin dapat natin na formula is ito. YZAV or Y zero air void is equal to GS or GS times unit weight of water divided by 1 plus moisture content times specific gravity, or ang unit weight of water divided by the moisture content plus 1 over specific gravity. So since meron na tayong mga values nitong unit weight of water, moisture content, and ang specific gravity, ang gagawin na natin is to plug in the values para makuha natin ang zero air void unit weight dito. Okay? Plug in mo lang dyan. So for example dito, ang unit weight natin, so ang ginamit natin na unit weight this time is ang 9.807 since ang ating volume is nasa cubic centimeter. Okay? So again, sa zero air void unit weight is 1 divided by 1 plus divided by moisture content, this one, moisture content plus 1 over ang ating specific gravity, which is 2.68, close. Yan. Para makuha ang ating zero air void. The same formula pa rin again sa pagkuha ng zero air sa different na mga values ng ating moisture content. Then, remind ko lang again, dito sa moisture content natin, mag-assume dapat tayo ng mga values nito. So, dapat, the best values is yung nagkakasunod-sunod ng mga values. Okay? So, to plot this table, dito tayo sa insert, chart. Okay. Hingi tayo ng, teka. Okay. Insert, chart. Dito, okay. Select data. Now, this one, remove natin yan. Add tayo. This would be the MPCT. Now, for X values, again, ang X values natin is ang ating moisture content. Okay? Ang ating Y values ay ang ating dry unit weight. Okay? There we go. So, ito pa lang ating na-graph. Itong part pa lang na to. Mag-add naman tayo ng ang ating curve for our zero air void curve. Zero air. For X values, itong moisture content. And ang Y values is ang ating zero air unit weight. Now, as you can see, sa ating final output sa ating chart, hindi nag-intersect ang ating values dito sa first chart o sa first table dito sa ating zero air void curve. Okay? So, at least ma-identify natin kung ang ating table or ang ating data is mag-intersect sa zero air void curve or hindi siya mag-intersect. Okay? So, yan lang ang modified Proctor compaction test and how to calculate the values. I hope na may natutunan kayo and I'll see you guys on the next video. Goodbye.